We're going to solve this exponential equation using the property of equivalence. This property states that if you can set up the equation to where both sides are the same, then you can bring down their exponents, set them equal to each other, and solve for x. So let's proceed with finding the common base. So if we look, we have a base of 4 and we have a base of 8. And we want to know, well, can we make both have the same base of 4? So looking on the left side, if we put a 4 here and we raise 4 to some power, will it give us 8? No, because if we have 4 and we raise it to the second power, it's going to give us 16. So it's not going to work with having the same base of 4. What about over here if we make this base an 8? Well, we can raise 8 to any number and it's not going to give us 4. So that's not going to work either. So we look inside each number, inside 8 and inside 4. They both have a 2. So why don't we try 2? 2 will work. Yes, it will, because if I raise 2 to the third power, it's going to give me 8. And if I raise 2 to the second power, it's going to give me 4. So let's rewrite both bases. Now, the bases are still not by themselves. We need those two to be by themselves. So what we have to do is distribute their exponents. So on the left side, that's going to be 3 times x, which is 3x. 3 times 2 is 6. On the right side, 2 times x is 2x. 2 times negative 3 is negative 6. And now that we have the bases by themselves and they are the same, the property of equivalence states that I can now bring down the exponents, set them equal to each other, and solve for x. So to solve for x here, I'm going to subtract 2x from each side and subtract 6 from each side. Combine like terms, and x equals negative 12.